Right, before we continue too much, I've got to still clean up a bit more of the corrosion on the battery terminal. This is where the battery went. This is our positive connection. I think it's a positive connection here. Give that a bit of a clean up. It's a bit verdigris on that, but it's not bad. It's not corroded badly. And then what I'm going to do is put some conformer coating on the tracks that are where the solder resistors come off. And then we'll try and find a place where we're going to install our regulator. Now probably we'll just follow with what the other chap did on the internet, but you can see that verdigris there needs to be cleaned up. Get that in. What I might try is it on the ohms range without the series regulator, just to see what we get and see if the ohms range is actually working before we get too carried away with fitting regulators and things like that. At least we know that the rest of the circuit's working. If I fit the regulator it doesn't work properly, we know what's wrong. Right, so having a look at this, I've just put the bloody battery around the wrong way, and the trouble is, if you put the battery around the wrong way, it's a pretty crappy design. It shorts the battery out because that clip is connected to the positive. So you put that to the negative, which I did, it shorts the battery out. So that's a bad design. So I think the battery's okay, but it started to get warm, but it wasn't in there for long, so hopefully that's okay. So here's our connection. It's our positive connection. It runs around here to this point here. This is where I think I'm going to insert the regulator. So I'm going to put the input of the regulator this side of the track, the output the other side, and then find a suitable ground point. And the suitable ground point will just run this straight back to this connection here. That's easy. I think we might need to put up maybe a capacitor across one of the control rails. I'm not sure if it's got a control pin that just needs to be filtered just to keep the stop it from oscillating or anything like that. Shouldn't think that's necessary. So the first thing we'll do is we need to cut that track out, so bring it down lower. So what I plan to do is to cut the track with a sharp knife. I've got my glasses on so I can see a bit easier. So the plan is to cut the track somewhere where we've got a bit of room to work. So here's say again, let's make sure you're in the shot so I can show you what I'm doing. This is our point here. This is our positive track. It comes around here. So if I cut here, cut the track, make sure I break the track. I can see with the copper's cleared. I've got a clean break there. So that track's broken. Now what I need to do is just scrape the solder resistor away. If I can zoom in anymore without the camera going out of focus. That's about there. It's about as far as I'm going to get. Scrape the solder resistor away either side. This like that. And the same on the other side. Make sure you get a nice clean area so we can solder to. Oh, the cat's just walked in. Hello, Piggy. The cat's been playing with the laser pen. Hello. Doesn't usually come in here. I think he thinks it's a bit dodgy in here. He's sitting under the chair now. I don't think he'll come up on the bench like Jim's cat does. But so that's that track cleared. So that will be on the right hand side here. Will be our input to the regulator. That's our output to the regulator. So all I've got to do now is buzz out a connection to the ground connection. So the ground connection is, well, there's one here. This is the ground here. So all I need to do is run a link from the other pin of the regulator to here, and that should be our negative connection. So let's get this a bit prepared, ready for installing the chip, and see if this works. Okay, zoomed in so you can see what I'm trying to solder with. Solder with. This is the little chip here, tiny little thing, and that's our low dropout regulator. So I've just got to work out the pin outs, then I've got to try and solder one pin to the out, one to the in, and the other to ground. That should give us our regulation. So it should be fairly straightforward. Just got to look up the pin out. I'll have to get some finer solder out, prepare the tracks so they're all ready, so it should just flow straight away. I have had experience with stuff like this, believe it or not, so small as this, so I should be okay. It's just the tracks are much thicker than I'm usually used to working with stuff at work. But let's try and get this cleaned up, ready to install it, and see if it works. A little sod to get in. It's absolutely tiny. This is the maximum magnification I can get with the lens, as close as I can get a maximum zoom before it goes out of focus. That's the device there. There is a problem. The problem is the 1.5 volt battery is not enough volts to make this regulator turn on. It's got an under voltage lockout in its circuitry basically. So what I'm going to have to do is try and find something greater than 1.5 volts. 3 volts would be fine, maybe 3 volts, 4.5. That's going to be easy enough. I can put a couple of coin cells in series, and then once we got that working, we should be able to get it to work. Now, let me just demonstrate that by, I'm going to connect an external power supply to it. I'll set my external power supply to about 3 volts. So what I'll do is I'll just connect this up just to show you. Okay, and the lead's not very long, so I'm going to have to move it over so you can see a bit over here. Right, connect a lead up for the ohms range. And you see we've got full scale deflection, and it's off the scale, but we can adjust that with the trimmer pots. If I just turn it down to 1.5 volts, this is about 3. Yeah, that's about 1.5 volts. You just see the regulator just stopped regulating, dropped out, increased the voltage. So there we go. So basically what I've got to do is I've got to find, duplicate, maybe try and get a 3 volt one of these. I think people make a sort of different package for this, so we can make this into a sort of, get a 3 volt version, or as I say, just tape sort of like a number of them in series and use that. So that will be the next option, is to try and just get the header volts up, then we calibrate the meter, and then we should have ohms range working perfectly well. Right, I've ordered some batteries, 16mm diameter, so I can put more than one in series. They're 3 volts each, so I can actually go up to about 9, 12 volts, that'd be fine, while I'm in series, and just make sure they don't short out together. In the meantime, look at this meter movement. We knew that the meter was highly underdamped before the switch contacts were made clean, and the whole meter was loaded down to the circuit, and there was a bit of resistance across the meter. It's basically shunted, basically. But there is a bit of room for improvement possibly, and I thought you might like to see the difference between the meter's standard now, and if you just move it about, you see how it swings about. It's not bad, it's fairly well controlled, but you see the way it's still a little bit, sort of takes a little while to settle. Let me just show you if I add a capacitor. This is a 33 microfarad capacitor across the meter movement. Just show you the difference. Not very scientific, I know, but you can see the difference. So this is a 33 microfarad capacitor across the movement. See how much more controlled it is. Now the only drawback probably would be that was if you were measuring AC that was rapidly changing, or even a DC signal, of course, that was rapidly changing, the meter would be very slow to respond to that. There are a number of good things about putting a capacitor like that across the meter. One of them is, if you're going to accidentally overload the range on the meter itself, you have got diode protection on here, which will stop it from burning the movement of the meter out. But what the other problem could be is if the meter pegs across so quickly, it can actually physically break the meter. It can actually bend the meter itself, bend the needle, and basically scrap this meter. With this capacitor across there, it will slow that transit down. So if you apply a voltage rapidly, you'll see it will move across very quickly, but it will actually reduce the inertia when it hits the end stop, because it's not travelling quite as fast. So I might actually just install that capacitor and just see how we get on. It basically goes across the meter here. There's the connections, and I can just fold it underneath. It's only small, low voltage capacitor. And this one's, as I say, 33 microfarad. I don't want any more than that. You could actually overslug them, and they're just so unresponsive. You could actually reduce it to sort of like, I don't know, a 12 microfarad. But I think that's quite good. I like that. It looks a bit more controlled. It's less likely to get damaged if you give it a real shake about, because the movement's so heavily weighted. So anyway, wait for these batteries to turn up, and we'll see how we get on. The batteries have come today, and what I've installed are some CR1632s, and you can see them here. But I've put what's that, 5 in series, so 5 3, that's 15 volts. So that regulator can easily compensate for that, and no problem with over dissipating in the regulator or anything like that. So let's just turn it around and have a look, see if we make sure our scale doesn't just peg itself. You see we've got a nice controlled movement. So all I need to do now is adjust the 3 pots. We can get that in view. So we've got full scale deflection. We're just past full scale deflection at the moment, but we need to adjust the 3 potentiometers. So I'll find out which 3 pots we need to adjust to hopefully bring that to 0 ohms, and that should be working. So basically what we're doing, just to sum up, is we've got the 12 volts fed into this little surface mount regulator here, and that's producing 1.35 volts. The regulator is very slightly warm to the touch, actually. Can feel heat through that regulator, and I could reduce that by actually reducing the voltage on the battery. That would reduce the dissipation. We are in the times 1 ohm at the range at the moment. Actually, we could try on the times 1 ohm range, make sure it doesn't get too warm. But the dissipation I expect to be still very low. Yeah, it's warm to the touch, that thing, but it's certainly not a problem. That should be absolutely fine. So let's try and trim this up and get our ohms range set to 0. Right, let's see if we can bring this in then. So we're on the times 1 range, I short the leads together, and we need to adjust, for the times 1 range, we need to adjust R30, and R30 is, where is it? I saw it just now. There's R30, that top pot there. Let's get our screwdriver in there so we can bring that in. That's a normal screwdriver, it's a big slot on that. I should bring our 0 ohms in. There we go. You can see this because obviously you're going to probably get a bit of parallax, but that's perfect. We'll try it on the times 10. That's a little bit low now, so times 10, there's another adjustment for times 10. That's R31. Let's find that. That's this next one around. Pot's a little bit noisy. A little bit of work. Perfect. Times 100, and this is the last adjustment. This won't affect any of the other calibration on it. This is R22, or sorry, R32, which is just below it. Yep, just confirm R32. That's more or less spot on anyway, but bring it just gone the wrong way, wrong range. R32. There we go. That's why it was spot on, because I'd already done that range before. So it's the times 100 range, times 1 range, times 10 range and times 1 range. Times 1 range is a little bit low, just bring it up a little bit higher with the other screwdriver. Oh, okay. There we go. So that looks good to me. So we've got our ohms range working, and it works perfectly. That's going to be good, because it means that these batteries, you know, they will last more or less forever, because they're going to have to drop down to about 2 volts before this regulator can't supply enough voltage and goes under voltage lockout. So that's basically completed the repair on this lovely Metrix meter. Really nice meter. Been really enjoyed working on this. I hope this video is interesting. I hope that people are going to, maybe if they see these, they're going to use this video to repair theirs and make theirs working again. Easy enough to replace the battery with something better, and put a regulator in, and you've got a decent meter. Thanks for watching. More to come.